Hello everyone. Today we are going to start the last point of this topic, that is the analytical and synthetic evidences for the nicotine. In last lecture we have seen the structure for nicotine, that is here the structure for nicotine. Okay, this is the structure for nicotine. As far as its occurrence is considered, nicotine is an alkaloid of a tobacco which is a salt of a citric or malonic acid salt. Okay, in tobacco it is occurs as 0.6 to 8%. Okay, as far as its nature is considered, it is colorless, oily liquid when it is freshly prepared. But when on exposure to air, it becomes a brownish in color. Okay, and its a dose, that is if sufficient, not sufficient, that is equal to 50 mg, which is harmful or injurious to the death of a man, that is it is a poisonous liquid. As far as its solubility is considered, here it is soluble in water and organic solvents. As its salts are dextrorotatory, the nicotine itself is a levorotatory. And therefore its mutual rotation, that is equal to its alpha is equal to 168.4. Okay, as far as its levorotatory, its mutual rotation is equal to 168.4. Now we have to discuss the analytical and synthetic evidences for the nicotine. See here, first point, analytical evidences. Now analytical nicotine evidences are, as far as considered, there are 5 points. Which are the 5 points? First point is about molecular formula. Okay. Second point is nature of nitrogen atom. Second point is about nature of side chain. Fourth point is about Pioneer proposed 2 structures for nicotine. And last point is about Carrier gives the evidence proof for nicotine structure. In these points, we have to explain the analytical evidences for the alkaloid named as a nicotine. The first point is about, that is the molecular formula. As far as molecular formula is concerned, its molecular formula, that is for nicotine, that is equal to C10H14N2. Okay, which can be here as, see the structure here. Before drawing, I am just coinciding with the structure as it is here. That is, this is the structure. Okay, how many carbon atoms are here? That is 1, 2, 3, 4, 5, 6, 7, 8, 9 and here 10. Okay, H14 what? 3. Okay, 5, 7, 9. Okay, then 10, 11, 12, 13 and 14. Okay, and 2 of the nitrogen atoms. Okay, now Second point is about nature of nitrogen atom. In this nature of nitrogen atom, we have to discuss the 3 points. Which are the 3 points? First is, that is the reaction with acylating agent, reaction with benzoylating agent or benzoyl chloride, and the reaction with a CH3I. Okay. Now, as far as these 3 points are considered, already we have discussed these points in the general methods structural determination for an alkaloids. Now, in case of nicotine can't give the taste with a acylating agents. Okay, it can't give the taste with a benzoyl chloride or benzoylating agents, but it gives the reaction with a methyl chloride. There is formation of a dimethyl iodide salt. Okay, the reaction is like this here. See here the reaction. Nicotine, that is with CH3I, C10H14N2 plus 2 molecules of CH3I here gives rise to formation of, this is the addition reaction here. Okay, that is C10H14 here. We have to write here N2 as NCH3 twice and here I2. Okay, that is the addition, that is the nicotine diamide dimethyl iodide. Okay, that's this formation. Now again on the reaction with HCl, what is the reaction here? That is C10H14N2 plus twice HCl. There is formation of also a addition reaction here. There is formation of C10H. How much of here H is there? That is equal to 16 plus. So for 14 plus 2 is equal to 16 plus N2 plus Cl2. Okay. That is, as there is formation of the addition product with a dichloride of a nicotinic amide, it is indicated that it is a diacid base. And it is indicated as the N-based alkali and as a N-methyl base. In the first reaction, with the reaction of a methyl iodide, it gives the formation of nicotine diamide dimethyl halide, confirms that is presence of nitrogen base alkaloid with a NCH3 base, as well as with HCl, it gives addition reaction. There is formation of a C10H16N2 Cl2, which gives rise to conclusion that it is a diacid base. The third kind of reaction, that is nicotine on oxidation gives rise to nicotinic acid. See the formula here, C10H14N2 plus oxidation here in presence of MnO4 or a K2Cl2O7. There is formation of nicotinic acid. Structure of nicotinic acid is like this, COH. Thus the formation of nicotinic acid confirms that the presence of a nicotine alkaloid, that is presence of a pyridine nucleus. Now instead of this pyridine nucleus, what is the other side chain? See here. As here presence of this nicotinic acid concludes that presence of pyridine nucleus. Pyridine nucleus. Now what is about the side chain? Therefore, side chain is equal to what? Here we have to calculate here as, what is the formula for nicotine? C10 H14 N2 minus, what is the formula here? That is 1 2 3 4 5 C5 H how much? 1 2 3 4 okay 5. Here how many H? That is equal to, one of these is got here, that is equal to 1 2 3 4 5 H, okay, and N here. What is the remaining here? That is C5 here, C5 H of how much? That is H 9, okay, and N. That is this type of the molecular formula of a side chain is present in a nicotinic nucleus of a pyridine basic ring. Okay. Now the next point is, that is presence of a side chain here. Presence of side chain. Nicotine on reaction with a which, that is the oxidation, it can give rise to the formation of a nicotinic acid. Now as far as this side chain is considered here, when nicotine is heated at 473 to 573, it gives rise to the one molecule of CH3NH2 per molecule of nicotine. Per mole of nicotine. That it confirms that is in the side chain there is presence of a NCH3 group here. That is which indicates that NCH3 ring group must be present in side chain. Again, this can be proved by using the distillation of nicotine with a zinc chloride. That is distillation of nicotine with zinc chloride, 2H2. That is C10 H14 N2, okay, ZnCl2, okay, 2H2O on distillation here. Distillation gives rise to 3 units. Which are 3 units? First is pyridine, second is pyrrole, and third is methylamine, CH3NH2. Okay. Now the presence of this, which is first is, this is a pyridine, this is a pyrrole, and this is a methylamine. Now presence of pyrrole, which confirms that in the side chain must be of a pyrrole ring. pyrrole ring. And what is our pyrrole ring here? And this pyrrole, it must be a saturated one. Pyrrole ring. Now how it is saturated first? For this we have the evidences are, see here. Nicotine on reduction requires 3 moles of H2. We suggest that the side chain of pyrrole, the side chain of nicotine must be saturated one. Must be a saturated one here. Okay, that is nicotine on reduction. That is C10, H14, N2 plus thrice H2. There is formation of what? That is C10. How many? H20. That is equal and N2, which concludes that is the side chain must be either saturated one here. That is of a saturated ring. That is of a pyrrole ring. Okay. Now the presence of N-methyl in a side chain along with a pyrrole ring suggests the formula for the nicotine according to the scientists suggest that is the formula for this is equal to Piner, according to a Piner scientist, according to scientist Piner, the formula for nicotine is as follows here. First is either structure A or this is a 1, 2, 3. This is a 1, 2, 3. This is a 1, 2, 3, and this is a 1, 2, 3. Now either 3, 2 linkage, okay, or either 3, 3 linkage. That is the structure for nicotine. Okay. Now, which structure is the correct one here? The question is arises now. Now, suppose this structure is correct or this structure is correct. For this structure is correctness, here, according to scientist Piner, he gave a evidences as a proof for the structure is equal to a. See here, what is the evidence? According to Piner, nicotine C10H14N2 on reaction with Br2 oblique HBr, okay, in following the presence of a heat that is equal to BaOH twice as an hydroxide, it gives rise to 2 acids and 1 mole of methylamine. Okay, now which are the acids here? First 2 acids are, first is malonic acid, okay, and second one is the nicotinic acid. Okay, what are the structures are found here? This is the nicotinic acid, already I am saying this, that is COOH. And what is the malonic acid here? That is CH2, COOH, COH. This is the malonic acid here. Okay. Now for this, again the scientist Piner gives as a structure 1. For this, as a structure 1, as here I am drawing to this structure, that is NCH3 here. Okay. On the breaking of the bonds, which are denoting the structures like this here, in these bonds the structures are remaining. What is this bond, and here also these bonds. Okay. Now this bond and this bond, on breaking, it gives rise to the nicotinic acid, malonic acid and the methylamide here. Also he gives the another proof for this nicotine as, see here, first is, again I am writing here, that is BaOH twice. Okay. Here formation of this which acid, that is first is malonic acid. This is malonic acid plus nicotinic acid here. Second, methylamide. Now, second evidence for the structure, that is a structure called as a first, that is on nicotine here. Here the reaction is like this here, as that is the reaction on this is Br2 in acetic acid, H2SO3 plus H2SO4 here, formation of a acetyl pyridine plus oxalic acid, COH bond COH, okay, plus methylamide. Okay, acetyl pyridine, here oxalic acid, and here methylamide. Okay, this is the second evidences. Now the second evidences is what? That is nicotine, which is the correct structure for this according to the scientist as a Piner. It gives the evidence there, that is bromine in acetic acid, H2SO3 plus H2SO4 gives rise to the, in acetic acid is the COH, COCH3 group attached to this pyridine nucleus, therefore acetyl pyridine with formation of a oxalic acid and the 1 mole of a methylamide. With these two evidences clears that the structure 1 is the correct structure for the nicotine. Now the second scientist, that is a Carrier, gives a very good proof, that is a practical proof for the structure 1, that is the correct structure. What is the, according to a Carrier scientist, see here, according to Carrier here, what are the steps here? According to Carrier, nicotine on reaction with first HI. Okay, what happens here? See the reaction here, that is nicotine on accordance with a HI, here formation of NCH3 HI in the reaction of a CH3I here, the formation of first CH3 and here I, that's the NCH3 here. Then according to which, that is this position is here on, this is on a oxidation, K3FeCN6 potassium ferricyanide gives rise to the formation of here and which is on again a oxidation with CrO3, okay, give rise to the formula that is known as here that is a formation of a hygrinic acid. Hygrinic acid. Okay, what is the according to carrier here? First, this is a nicotine on reaction with hydroiodic salt. There is formation of iodide derivative of a nicotine. Then again reaction of a methyl iodide here. There is formation of iodomethyl derivative of a nicotine here, which is on oxidation in presence of a which, that is the mild oxidizing agent, that is potassium ferricyanide in presence of a NaOH. There is formation of this structure, that is NCH3 here. This is the oxidation one here, formation of double bonds here. This double bond position gets changes here, and with a mild oxidizing agent, that is a CrO3 here, CO group is oxidized into a CH2. Okay, thus there is formation of this compound called as a hygrinic acid. Now vibration of hygrinic acid confirms the structure of nicotine is the correct one, that is the 1, 2 and 3, and here 1, 2, that is 3-2 linkage. As I am stating in previously, that is 3-2 linkage, that is structure 1 is the correct structure for the nicotine here. Okay, thus we have completed here analytical evidences for the structure of a nicotine 1 here. Okay, thus the structure of nicotine will be as what is the structure here? That is this structure. This is the correct 1, 2, 3 and 1, 2. That is 3-2 linkage is the correct structure according to carrier. Okay, thus this is the correct structure. Now this structure can be corrected by using the Sugasawa's synthesis. Now we have to see here synthetical evidences, that is from a nicotinic ester. See here what are the reactions are here. First, just I am concentrating to see the video here carefully by means of a nicotinic ester here, that is synthesis of nicotine. In the synthesis of nicotine, first step is nicotinic ester. COO C2H5. This is called as nicotinic ester, which on reaction with, that is malonic ester, which is on reaction with a succinic diethyl succinate. Reaction alternate is diethyl succinate. Here, in presence of a C2H5ONA. Okay. Now, what is the reaction here? This is called as a nicotinic ester. That is COO, C2H5, and here pardon. This is called as, that is CH2, COH. That is, it is called as a succinic ester. And when ester group is attached to it, it is called as a diethyl succinate. Now, what is the synthesis? Here, first, that is the removal of this C2H5O and their H. This H is written as this. Okay, this H and this C2H5. That is minus C2H5OH. Here formation of, I am writing here, that is at this time here N, here CO. Okay, C double bond O here. What I mean is, that is, this group is going on this. Okay, therefore CH. Okay, CO, O, C2H5. Okay, CH2, COO, C2H5. Here again, the hydrolysis 5%, 5% HCl. Which timing hydrolysis? That is here OH, H, here also OH and here H. Okay, that is plus 2 H2O. What is the remaining one here? Minus C2H5 OH minus C2H5 OH. This minus 2 C2H5 OH. Okay, got it? What is the remaining one here? See here. That is, this is now CO. Okay, CH, COOH. Okay, CH2, COOH. Okay, now what is the next step here? Now the next step is here, from here I am writing here as a decarboxylation. Decarboxylation means what? A removal of a carbon dioxide here. That is from which carboxylic group? That is from this. That is CO2. Okay. Now from here CO2. The structure is like this here as, that is N. Okay. CO. Okay. Then CH2. CH2. Here CO2. This H comes to here. Therefore CH2. CH2. COH. Again on ester here, C2H5 ONA. Okay, here what is the remaining here? That is minus NaOH. Okay, that is, there is formation of, see the, this is the N nitrogen here, CO. Okay, CH2, CH2 here, COO, C2H5. Okay, now on the reaction here, that is lithium LaLH4 reduction here also, and here also what? That is minus C2H5OH, minus C2H5OH here. What is the remaining here? Now how the here the ring is can be formed here in this way. Here the formation of a ring as seen here, that is here the formation. Before this step we can also use, if this is before this step we can also use which step? Like that. That is equal to what? That is a CH3NH2. CH3NH2 also. Okay, this is H2, this H2 and here O. Okay, then removal of a water molecule here. There is formation of this NCH3 get attached to on here. That is N here. Then C double bond N CH3 here. Okay. Then also CH2, CH2, here COO, C2H5. Okay, now on reduction, partial reduction, NaHG, reduction here. What is the formation of here? See here. CH, single bond NH, and here CH3. Okay, this bond is glued here. Okay, thus here CH, okay, CH2, then CH2, and here COO, C2H5 here. Okay, now the last step, that is equal to reduction LiAlH4, and here this is now here in this LiAlH4, by using before this thing, setting this, one more step is remaining here, that is hydrolysis. That is, it can give rise to what? That is this C2H5OH, and here also H. Thus there is formation of N here, then CH, CH2, then also CH2 here, okay, here CH2, then CO minus C2H5 OH, okay, and here formation of a N, and here also a CH3. Now here ring formation LiAlH4. This CO group can be reduced to a CH2 group, and there is formation of the structure called as a nicotine 1 here, as this is a CH, this is a CH, this is a CH2 here, this is a CH, CH2 here, then here also a N, CH3. This is goes down here, N, CH3. Okay, thus 1, 2, 3, 4, 5. Thus this is the structure of a nicotine. That is 1, 2, 3, 1, 2. Okay, thus we have explained the synthetic evidences. This synthetic evidences for an alkaloid called as a nicotine 1, and this synthesis is called as a Sugaseva's synthesis. The synthesis is called as a Sugaseva's synthesis. First step is what? That is by using the nicotinic ester and diethyl and the diethyl malonyl ester here. Sorry, succinic. Ethylene succinate here, ester here, when we are getting the added product. Then on hydrolysis, then on again hydrogenation, then on again the hydrolysis, we come to the required product, that is called as a nicotine 1. Thus we have synthesis, Sugaseva's synthesis according to the formation of a structure of a nicotine. This is the correct structure for the nicotine, and thus we conclude this chapter namely as the natural products. Okay, if you have any difficulty in these chapters, you can ask me on my group. Okay, so my request to all the students, please write this synthesis in the correct form as I am giving to you and practice it, okay, for your future exams. Thank you.